Yo, welcome back to the deep dive by Summit Neuro, episode 15, and we are in chemistry territory today. Chemical kinetics. The chapter that answers one simple question. कितनी स्पीड से रिएक्शन होगा?
भाई स्पीड तो मुझे भी चाहिए। मेरे नीट प्रिपरेशन की स्पीड तो दिल्ली की ट्रैफिक जैसी है, सब कुछ रुका हुआ है।
Bro, that's exactly why this chapter matters. NEET में consistently 2 to 3 questions आते हैं from chemical kinetics. डायरेक्ट फॉर्मूला बेस्ड। अगर तुम ये चैप्टर सॉलिड कर लो, गारंटीड मार्क्स है।
और ये चैप्टर वो है जहां कोचिंग वाले सब कुछ फॉर्मूला डंप कर देते हैं। DW के लेक्चर्स में 47 फॉर्मूलाज लिख देते हैं व्हाइट बोर्ड पे, बच्चे रोते रहते हैं। ड्यून एकेडमी में एनिमेटेड वीडियोस डालते हैं, बच्चे सोते रहते हैं। लेकिन कॉन्सेप्ट समझो तो फॉर्मूलाज खुद डिराइव हो जाते हैं। आज हम वही करेंगे।
Ma'am, I actually like this chapter. It's very logical once you understand order and molecularity.
Mahakale, exactly right.
It's Mhankale, ma'am. Mhankale. Every single episode.
इतना मारूंगी ना तुझे। चल, let's start. Chemical kinetics is about two things: how fast a reaction happens and what factors control that speed. Thermodynamics tells you if a reaction can happen. Kinetics tells you if it will happen in your lifetime. Diamond converting to graphite is thermodynamically favorable, but has it happened? No. Kinetics says the rate is so slow you'll die waiting. That's the power of this chapter. Rate of reaction. Definition: change in concentration of reactant or product per unit time. For a reaction A arrow B, rate equals minus delta concentration of A over delta T, which also equals plus delta concentration of B over delta T. Minus sign for reactant because concentration decreases, plus for product because it increases. NEET trap number 1 right here. Students forget the minus sign for reactants. Instant wrong answer. अब अगर reaction है 2A plus B arrow 3C, then rate equals minus 1 over 2 into delta A over delta T equals minus delta B over delta T equals plus 1 over 3 into delta C over delta T. Stoichiometric coefficient से divide करो। NEET में directly पूछते हैं, if rate of disappearance of A is 0.2 moles per liter per second, what is rate of appearance of C? Stoichiometry से निकालो 0.3 moles per liter per second.
भाई ये तो जोमेटो डिलीवरी ट्रैकिंग जैसा है, कितना खाना गया कितना आया सब रेट में।
अच्छा एनालॉजी। अब रेट लॉ। रेट लॉ कहता है रेट इक्वल्स k इंटू कॉन्सेंट्रेशन ऑफ A to the power x इंटू कॉन्सेंट्रेशन ऑफ B to the power y. यहाँ k is rate constant, x और y are orders with respect to A and B. x plus y equals overall order. Critical point: order is determined experimentally. You cannot just look at the balanced equation and write orders. ये सबसे बड़ा NEET trap है।
But molecularity you can get from the equation, right?
Yes, और यही difference है। Molecularity is the number of molecules taking part in an elementary reaction. It is determined from the equation, but order is experimental. Mnemonic: OEME. Order is experimental, molecularity from equation. याद रखो OEME. More differences. Order can be 0, fractional or negative. Molecularity is always a whole positive number, 1, 2 or 3. Molecularity greater than 3 is practically impossible because the probability of 4 molecules colliding simultaneously is almost 0. Order applies to overall reaction. Molecularity applies only to elementary reactions. If a reaction has a mechanism with multiple steps, molecularity is for each step, but order is for the overall observed rate law.
Ma'am, so for a complex reaction, the rate law is determined by the rate determining step, correct?
Mahakale, perfect.
Mhankle, मैंने टाली बंदू।
Rate determining step. वो स्टेप जो सबसे स्लो है वो बॉटलनेक है। जस्ट लाइक दिल्ली का ITO क्रॉसिंग, पूरी ट्रैफिक उधर रुक जाती है। रेट डिटर्मिनिंग स्टेप का मोलेक्युलैरिटी डिटर्मिन्स द रेट लॉ ऑफ द ओवरऑल रिएक्शन। NEET loves this concept. अब integrated rate equations. ये formulas है, but अगर concept clear है तो derivation से याद रहते हैं. Zero order से शुरू करते हैं. Zero order. Rate equals K. Rate constant पे depend करता है, concentration पे नहीं. Integrated form. Concentration of A at time t equals concentration of A initial minus K number t. Graph. Straight line with negative slope. Concentration versus time plot में सीधी line नीचे जाती है. Half life for zero order. T half equals concentration of A initial divided by 2 minus K. NEET point. Zero order half-life depends on initial concentration. जितनी ज़्यादा initial concentration, उतना लंबा half-life. This is opposite to first order.
भाई जीरो ऑर्डर मतलब रिएक्शन को कोई फर्क नहीं पड़ता कितना रिएक्टेंट है. ये तो मेरी माँ जैसी है, मुझे डांटेगी चाहे मैं कुछ भी करूँ.
बिल्कुल, surface catalyzed reactions में होता है ये. जब surface saturated है और reactant डालते जाओ, rate नहीं बढ़ेगा. Example, decomposition of ammonia on platinum surface at high pressure. NEET में ये example पूछा है. AB first order, most important for NEET. Rate equals K times concentration of A. Integrated form. K equals 2.303 over T into log base 10 of concentration of A initial over concentration of A at time t. या फिर ln of A initial over A at time t equals K minus T. Half-life. T half equals 0.693 over K. Critical. First order half-life is independent of initial concentration. ये NEET का favorite question है. Half-life of a first order reaction is? Answer में initial concentration का कोई role नहीं.
So radioactive decay is first order, right? That's why we say half-life of carbon-14 is 5,730 years, regardless of how much carbon-14 you start with.
Exactly. Radioactive decay is a first order process. All radioactive half-lives are independent of the amount of substance. NEET asks, the half-life of a radioactive element is 30 minutes. What fraction remains after 2 hours? 2 hours is 120 minutes. That's 4 half-lives. Fraction remaining equals 1 over 2 to the power 4 equals 1 over 16. Simple.
Ma'am, for the graph part, first order gives a straight line when we plot log of concentration versus time, not concentration versus time directly.
Mahakale, spot on.
Mahankale, 3 for 3 today.
Ha. Plot of ln of A versus T gives straight line with slope minus K. Plot of log base 10 of A versus T gives straight line with slope minus K over 2.303. But if you plot concentration directly versus time, you get an exponential decay curve, not a straight line. NEET loves graph-based questions. Mnemonic. FLS. First order, log plot, straight line. FLS. Remember it. Units of K for different orders. Zero order, moles per liter per second. First order, per second. Second order, liters per mole per second. General formula, units of K equals concentration to the power 1 minus n divided by time, where n is the order. NEET में directly पूछते हैं. Unit of rate constant for a second order reaction. If you know the formula, 2-second answer. अब Arrhenius equation. ये chapter का heart है. K equals A times e to the power minus e minus a over r minus t. K is rate constant. A is pre-exponential factor या frequency factor. E minus a is activation energy. R is gas constant. 8.314 joules per mole per Kelvin. T is temperature in Kelvin. Log form ज़्यादा useful है for NEET. Log K equals log A minus E minus A over 2.303 minus R minus T. To temperature form. Log K minus 2 over K minus 1 equals E minus A over 2.303 minus R into 1 over T minus 1 minus 1 over T minus 2. ये न्यूमेरिकल्स में डायरेक्ट यूज होता है. नीट में वैल्यू देते हैं k माइनस 1, k माइनस 2, t माइनस 1, t माइनस 2 और e माइनस a निकालवाते हैं. या E माइनस A देते हैं और K माइनस 2 निकालवाते हैं।
भाई इतने फॉर्मूलाज, ये तो मेरे एक्स के मैसेजेस से भी ज़्यादा कॉम्प्लिकेटेड है।
फोकस कर। अरेनियस प्लॉट, log K वर्सेस 1/t प्लॉट करो। स्ट्रेट लाइन मिलेगी। स्लोप इक्वल्स माइनस E माइनस A ओवर 2.303 माइनस R। इंटरसेप्ट इक्वल्स log A। स्लोप से E माइनस A निकाल लो। नीट ग्राफ में स्लोप देके E माइनस A पूछते हैं। निमोनिक फॉर अरेनियस AKERT, आंटी की एनर्जी रूम टेम्परेचर पे। A for frequency factor, K for rate constant, E for activation energy, R for gas constant, T for temperature. AKERT.
What about the effect of temperature on rate? The 10-degree rule.
Good question. Temperature coefficient. General rule. हर 10 डिग्री सेल्सियस राइज से रेट 2 to 3 टाइम्स बढ़ जाता है। Temperature coefficient equals rate at T plus 10 over rate at T, usually 2 to 3. But NEET में exact Arrhenius यूज करवाते हैं। ये rule of thumb है। Reason? टेम्परेचर बढ़ने से ज्यादा मॉलिक्यूल्स एक्टिवेशन एनर्जी क्रॉस करते हैं। मैक्सवेल-बोल्ट्जमैन डिस्ट्रीब्यूशन कर्व राइट शिफ्ट होती है। Collision theory. For a reaction to happen, 3 conditions. Molecules must collide. Collision must have sufficient energy. That means energy greater than or equal to activation energy. And collision must have proper orientation. Threshold energy equals activation energy plus average kinetic energy of molecules. Effective collisions are the ones that satisfy both energy and orientation. Rate depends on frequency of effective collisions.
Ma'am, this is where catalyst fits in, right? It lowers activation energy.
Mahakale, exactly.
Mahankale.
Catalyst provides an alternative reaction pathway with lower activation energy. Important, catalyst does not change the thermodynamics. Delta G remains same. Equilibrium constant remains same. Catalyst speeds up both forward and reverse reactions equally. It does not shift equilibrium. NEET trap. A catalyst changes the equilibrium of a reaction. False. It only helps reach equilibrium faster. Another trap. Catalyst is consumed in the reaction. False. It's regenerated. Factors affecting rate of reaction. 5 factors: concentration, temperature, catalyst, nature of reactants, surface area. For NEET, concentration effect is in rate law. Temperature effect is Arrhenius. Catalyst lowers EA. Surface area matters for heterogeneous reactions. Powdered reactant reacts faster than a lump. Nature of reactants. Ionic reactions are fast. Covalent reactions are slow generally.
Ma'am, NEET trap time. Let's do rapid fire.
Chalo. Trap 1. Order of reaction is always equal to molecularity. False. Order is experimental. Molecularity is theoretical. They can be equal for elementary reactions, but not always for complex ones. Trap 2. Rate and rate constant are the same thing. Wrong. Rate changes with concentration. Rate constant K is constant at a given temperature. Rate has units moles per liter per second always. Rate constant units depend on order. Trap 3. Half-life of all reactions is independent of initial concentration. Only true for first order. Zero order half-life depends on initial concentration. Second order half-life is inversely proportional to initial concentration. Only first order is special.
भाई फर्स्ट ऑर्डर को स्पेशल ट्रीटमेंट, ये तो टीचर्स पेट है केमिस्ट्री का।
हाँ, first order is the golden child of kinetics. Trap 4. Pseudo first order reaction is actually first order? No, it's actually a higher order reaction that behaves as first order because one reactant is in large excess. Example, hydrolysis of ethyl acetate in presence of excess water. Actual order is 2, but observed order is 1. NEET loves this example. Trap 5. Activation energy is always positive. For simple reactions, yes, but NEET में कभी-कभी पूछते हैं about the Arrhenius plot slope. Slope is always negative because minus E minus A over 2.303 minus R. Don't confuse negative slope with negative activation energy. E minus A is positive, slope of log K versus 1 over T is negative.
Ma'am, another common confusion. The difference between rate of reaction and rate constant's dependence on temperature?
Mahakale, excellent point.
Bhankale, I'm literally going to print my name on a banner.
Rate of reaction depends on both concentration and temperature. Rate constant depends only on temperature and activation energy. If temperature is constant, K is constant. Rate changes as reactants get consumed. K does not change during the reaction at constant temperature. Meet asks, which of the following changes during the course of a reaction at constant temperature? Rate changes. K does not. Trap 6. Integrated rate equation for first order. Students write K equals 2.303 over T log of A initial over A minus T. Then in MCQ, they see ln form and get confused. Remember, ln form is K equals 1 over T into ln of A initial over A minus T. The 2.303 factor converts between ln and log base 10. ln equals 2.303 times log. Know both forms. Cross-chapter link. Chemical kinetics connects to chemical equilibrium. At equilibrium, rate of forward equals rate of backward. Equilibrium constant Keq equals K forward over K backward. Both K values follow Arrhenius independently. Also connects to electrochemistry. Nernst equation uses similar log math. And surface chemistry, heterogeneous catalysis, adsorption affecting rate. If NEET gives an assertion reason combining kinetics with equilibrium, this connection is what they're testing. Quick recap. Rate of reaction, change in concentration per unit time, stoichiometric coefficients se divide karo, rate law is experimental. Rate equals K into concentrations raised to powers. OEME, order experimental, molecularity from equation. Zero order. Half-life depends on initial concentration. First order, T half equals 0.693 over K, independent of initial concentration. FLS, first order, log plot, straight line. Units of K, use 1 minus n formula. Arrhenius, K equals A minus E to the power minus E minus A over R minus T. AKERT. आंटी की energy room temperature पे log K versus 1 over T plot gives straight line slope minus E minus A over 2.303 minus R. Catalyst lowers E minus A, does not change equilibrium.
भाई मेरा ब्रेन की रेट ऑफ रिएक्शन बहुत स्लो है, मुझे कैटलिस्ट चाहिए, शायद एक कप चाय.
Chai is the catalyst of meat preparation. Activation energy कम कर देती है. डाउट आए तो टेलीग्राम पे प्रिया AI से पूछ लो, वो भी रेट इक्वेशन सॉल्व करवा देती है स्टेप बाय स्टेप.
नोट्स चाहिए तो desieducators.com पे सब मिलेगा, प्रीवियस एपिसोड्स भी वहां है. कमेंट में बताओ, अर्हेनियस इक्वेशन ज्यादा स्कैरी है या इंटीग्रेटेड रेट इक्वेशंस?
Honestly, the unit conversions scare me more than both of them combined.
Valid fear, Mahakale.
I have accepted my fate at this point.
Never accept defeat on NEET, beta. Next episode, we're doing biotechnology principles. rDNA technology, restriction enzymes, PCR, gel electrophoresis, cloning vectors, the full genetic engineering toolkit. तब तक पढ़ाई करो, अपने reactions की rate बढ़ाओ और OEME याद रखो.
This has been the deep dive by Summit Neuro. Keep your activation energy low and your rate constant high. See you next time.